In this video, I wanted to go over potential energy and kinetic energy. This first page is page 9 in your packet, and I'm going to focus on about halfway down and then the bottom of the page. So the equation for potential energy is written right here. It's mass times gravity times height. The mass has to be in kilograms, the height has to be in meters, and g is just gravity. So if you're talking about on Earth, it's 9.8 meters per second squared. So what you get from this equation, if you think about the units, the mass is in kilograms, gravity is meters per second squared, and the height is meters, and all of that is getting multiplied. So what you end up getting is kilograms meters squared per second squared, which really is the same thing as a joule. A joule is the amount of energy it takes to make a 1 Newton object, and that's what this N is, a 1 Newton object move 1 meter. And what we learned with newtons is that it is the amount of force it takes to make a 1 kilogram object accelerate by 1 meter per second squared. This is usually the part of the course where students start to get confused with all the different units that we have and the different equations. And if you keep the units straight in your mind and just generally what the units mean, for example, that a Newton is the amount of force it takes to make a 1 kilogram object accelerate by 1 meter per second squared, or that a joule is the amount of energy it takes to move 1 Newton 1 meter, it will make a lot more sense to you. And we're going to go through that as I do some examples with you. So I'm going to go down to the bottom of the page a little bit. And number 8. What is the potential energy of a 5 kilogram object 30 meters above the ground? So when we're talking about potential energy, that's mass times gravity times height. So the mass is given, that's 5.0 kilograms. This is occurring on Earth, so gravity is 9.8 meters per second squared, and then the height is 30.0 meters. You multiply all of that out, and assuming I did it right, you get 1,470. Now it's kilograms meters squared per second squared, because you have this kilograms, and this meters times this meters is where you get the meter squared. So kilograms meters squared per second squared, which is the same thing as a joule, so we'll just write it as joule. The next problem down has the same height, gravity is the same, so what they ended up doing is doubling the mass. And if you did the math for this, you would have the 10 grams multiplied by 9.8 meters per second squared multiplied by the 30 meters. All that stuff stays the same. It's just the mass that's changing. And it's pretty straightforward. You would just get double the mass. I'm sorry, double the energy, double the potential energy, 2,940 joules. Pretty straightforward with that. You double the mass, you double the energy. Now this one is saying 0 meters above the ground, so you would just have a 0 here. So you're multiplying everything by 0, so that's 0 joules in terms of potential energy. All right, so that's potential energy. Pretty straightforward with that. Now, kinetic energy, and this is page 10 in your packet, Intro to Kinetic Energy. We have a different equation. It's 1/2 mv squared. So if you think about the units, well, you have the 1/2. The mass is kilograms. Velocity is meters per second, but that is getting squared. So what you would get is kilograms meters squared per second squared, which is the same thing we had for potential energy, which is the same thing as a joule. So this whole idea of Newton meters still applies for this. So kinetic energy, and I'll go through a couple of these with you. What you get is kinetic energy equals 1/2 mv squared. So you have the 1/2, in this case the mass is 5.0 kilograms. Now remember, it's just the velocity that is squared. If you're going too fast, either you forget about the squared or you square everything. It's just the velocity that is squared, so I'm going to put that in parentheses. Now if you do this, if you look at the units, you get kilograms, and since this is getting squared, it's kilograms meters squared per second squared. Don't forget about the half. If you do all this correctly on the calculator, assuming I did it correctly, you get 22.5 joules. But remember, that's the same as kilogram meter squared per second squared. Now, number 8 is giving you the same velocity. It's just doubling the mass. So you'd have 5, you'd have 10.0 kilograms here. You'd have the 3 meters per second, that whole thing squared, that whole velocity squared. And when you do this, when you double the mass, what you would see is that the kinetic energy just gets squared. Pretty straightforward. Now, the next example, comparing number 7 and number 9, the mass is the same, but notice what's going on here with the velocity. The velocity is getting doubled. So I want to write this one out with you so we can pay attention to this one. You have the 1/2, the 5.0 kilograms, but now it's 6 meters per second, and that whole thing is getting squared. If you did the math for this, what you would end up getting is 90 joules. Notice the difference between number 7 and number 9. I doubled the velocity, but my kinetic energy is more than doubled. It's quadrupled, because what happened here is that doubling gets squared, and that's why it increases by a factor of 4. A good way to look at this is, let's say you had a 2 kilogram mass, and let's say it had a velocity of 2 meters per second, and you square all that. So the 1/2 times 2 kilograms gives you 1, the 2 squared, so all that turns out to be 4 joules. Now, if you double that velocity, and I'm just making these numbers up, you double that velocity, you do the math. This turns out to be 1. Really what happens is you're squaring 4, which gives you 16 joules. So when I doubled that velocity, the kinetic energy went up by 4. Now let's see what happens if I triple the velocity. It's going from 2 meters per second all the way up to 6 meters per second. Well, now when I do this, the 1/2 times 2 is 1, but 6 squared is 36. So see what happens here? I tripled the velocity between this example and this one, but the kinetic energy went up by 9 times because that tripling gets squared, which makes it 3 squared is 9. All right, so if you go through these other examples, you'll see that kind of trend. Just pay attention to the squared in that kinetic energy. All right, now this is the bottom of page 12, and I changed the format a little bit so it's easier for me to write a little bigger. I just wanted to go through some of these examples just to give you a little help, because at this point, like I said, we're doing a lot of different equations and it can get a little confusing. It's asking for potential energy, so as soon as I see that, I'm going to write down the equation for potential energy. Mass times gravity times height. It gives me mass in kilograms, which is what I want. It gives me the height in meters, which is what I want. And I know G is 9.8 meters per second squared. So this problem ends up being really straightforward. I have the 5 kilograms, I have the 9.8 meters per second squared, I have the height of 3 meters. You multiply all that out, you get kilograms, meters squared per second squared, because this meters gets multiplied by that meters, which is the same as a joule. You do that math, and I believe you get 147 joules. Again, pretty straightforward. Double check my math though, because I'm kind of doing this a little quick. This one's asking for potential energy again. It gives me the height, gives me the mass. I know G is 9.8 meters per second squared. The height's in the right units, the mass is in the right units. So if I just do mass times gravity times height, I will end up getting the right answer there. Again, straightforward for that one. Now, this next one switches it up a little bit. It's asking potential energy. And I'm used to doing this mass times gravity times height. It gives me the height, but notice it doesn't give me this mass. It gives me newtons now. And this is where it's a little tricky, because a newton, remember, is the amount of force it takes to make a 1 kilogram object accelerate by 1 meters per second squared. So a newton is the same as units, it's the same units as kilograms, meters per second squared. So what I could do is substitute this whole 25 newtons in for this mass times gravity, because if you think about mass times gravity, it's kilograms, gravity is measured in meters per second squared. So I get those kilograms, meters per second squared, which is the same unit as a newton. So what I could do is take that 25 newtons and just multiply it by 3 meters, and then I have my answer of 75 joules. Remember, you pretty much always want to get kilograms, meters squared per second squared. Well, what happens is the newton is the kilogram meters per second squared, and then it's getting multiplied by this meter, so I end up getting that. So you're just doing the force times the height. This one's asking you to rearrange the equation a little bit. It's asking for how high up. It's asking for height, so I know I need potential energy, because kinetic energy does not include height. So if I have my equation written out here, it's asking for height, so I want to solve for h. So what I'm going to do is get rid of the mass and the gravity on the left. And what happens is they cancel out. So what I end up with is potential energy divided by mass times gravity equals height. And if I write this out, 300, instead of writing joules, I'm going to write kilograms meters squared per second squared. The mass is 3 kilograms. The gravity is 9.8 meters per second squared. Now when you're doing this in the calculator, make sure you do it the right way. You might have to use parentheses here, right, because you want all of this on the bottom. A common mistake is to do 300 divided by 3 and then just hit times 9.8. That's doing a different order of operations. And when you look at the units, the kilograms will cancel out, the second squared will cancel out, that meters will cancel out, that squared will cancel out, and what you're left with there is meters. But pay attention, because a lot of times even when people set this up right, they do the order of operations wrong on the calculator. Maybe put some parentheses in there to make sure you get it right, and that will get you the right answer. All right, now the other part of the bottom of page 12. This is saying a 4 kilogram rock is rolling 10 meters per second. Find its kinetic energy. So once I see kinetic energy, I think 1/2 mv squared. The mass has to be in kilograms, which it is. The velocity is in meters per second, which is good. So I could just do the 1/2 times the 4 kilograms times 10 meters per second. But that is the part that's getting squared, just the 10. So when you do this, you really get this 1/2 times 4, which is giving you 2, times 10 squared, which is 100. So you have this 2 times 100, that's giving you 200 joules. And you're getting joules because you have the kilograms, and since this meters per second is getting squared, you get meters squared per second squared, which is the same as a joule. The next one down is asking the same thing, kinetic energy. Next one down, it's asking you to find mass. You have kinetic energy equals 1/2 mv squared. Now there's a little variation in how you do this, but I want to get mass by itself. So what I'm going to do is divide both sides by 1/2 v squared. Oh, I wrote that in the wrong spot. So now what happens is the 1/2 and the v squared will cancel out. So what you'll get is kinetic energy divided by 1/2 v squared equals mass. And if you think about the units there, the kinetic energy is kilograms meters squared per second squared, because that's what a joule is. You have the 1/2, you have the meters per second, but that is getting squared. So that's meters squared per second squared. So what you get is these cancel out. The only thing left will be kilograms. Again, make sure you do the order of operation right. Maybe put some parentheses around this. If you do it right, you should get the answer of, I think it's 4 kilograms. The next one's a little tricky. It's asking for how fast it is flying. So I'm going to start off with this 1/2 mv squared again. Now I am looking for velocity. So what I want to do is divide both sides by 1/2 m. And what I get right now is v squared equals kinetic energy over 1/2 m. But I have to get rid of this square. So I'm going to square root everything. So I get is velocity equals the square root of kinetic energy over 1/2 m. And if you think about the units, it'll be kilograms meters squared per second squared divided by kilograms. I have that 1/2 in there. But since all this is in the square root, the kilograms will cancel out. When you take the square root of meters squared per second squared, you will end up with meters per second. Do that on the calculator. Make sure you do all these problems that I'm helping you with on the calculator to make sure you're doing the order of operations right, because I am not there to double check on what you're doing. You should get 2 meters per second. All right, make sure to square roots in there. Make sure you use parentheses where you need them. The last problem here, we didn't do this yet. You could skip it for now. Work is really just force times distance. It's something we'll get into later. But that's pages 9, 10, and 12.